We want to let you know that this is being recorded, and we will be placing this webinar on YouTube for anyone who was unable to attend to follow up later on. Mike, it's all yours.
All right, fantastic, Lynn. Thank you. So appreciate everybody taking the time this morning to watch the webinar here. We're going to go over it as per the title, capabilities we have here at the Freeman facility. As Lynn mentioned, she'll be on in the background here, kind of keeping track of any of the chat and the questions. So as we go through it, we'll make a few stops along the way as it's necessary to answer some questions. And of course, at the end, we'll hang out as long as we need to with any follow-up questions or whatnot. So of course, provide some contact information at the end of the webinar for you to reach out and get in contact with us for any other questions or a visit or anything like that. So once again, thanks everybody for taking the time today. As Lynn mentioned, my name is Mike Mulholland. I am going to present today. We're talking about the Freeman Company here in Fremont, Ohio, where we specialize in thermoform tooling, paper tooling, and a few other various types of tooling that we'll talk about a little bit more in detail as we get through this. Company was founded in 1892 down around the Cincinnati area, where we specialized in items for the shoe industry. So when you think about wingtip shoes and all the pierced holes, all the little pieces of leather that go with that, that was what the company was founded on. A lot of patents and things like that around that type of tooling and what it took to make those shoes. Obviously, as that industry went away, we transitioned into just sharp edge dies. Could be anything from soft goods, cutting footballs, placemats, gloves, anything like that. It was our specialty, and we would do what we call high dies or forged dies, which some of you may know. And again, a lot of blacksmith type work, hand bent dies, welding, fabricating, things like that. Then in the 90s, we were doing tooling for some customers that had like sharp edge trimming in plastic, things like that. And we eventually got into building some molds for them and decided that was a good business for us. It was a good fit, a lot of opportunities. So in 1997, we built the facility that you see the picture of right here on the screen, and pretty much dedicated that building to the production of thermoforming equipment. We'll talk a little bit about that and some of the things we've done along the way and continue to do to stay at the forefront of capabilities and capacity and whatnot to be able to service that industry. Then our latest thing, back in 2018, we joined the Brown Machine Group. Fit into that really nice, where we have Brown, Lyle, from the two top machine builders that have combined forces with that. NAS that does packaging and things like that on the back end of it. And then we've just added Axotronics to the group, which specializes in robotics and packaging with that. So at this point in time, we've got a really vertically integrated group within the Brown Machine Group, and we can service many, many needs and offer a lot of knowledge and whatnot along the way to suit all those aspects of your business. So on that note, we'll get going. We're going to cover today, again, to present, just to discuss some of the things we do here at the Freeman Company that we think sets us apart from the competition, and mainly what it does to positively impact our customers along the way in terms of their business, their processes, their success in general. We're going to talk about our facility, our process in terms of sales, quoting, and order taking, the engineering that goes on, what we think we do different in regard to that gives our customers the best design tooling they can have out there. Our manufacturing capabilities that we're very, very proud of. Once again, some things that really set us apart from the competition. Our production methods, things like that. And of course, our people, which are really, really key to all this fitting together and making things happen every day. So starting off a little bit here about our facility. Once again, purpose-built back in 1997 for production of thermoform tooling, machine shop, aspect of that. A lot of high-end CNC machinery that we'll see as we move forward. But a couple of things just about our facility that set us apart. Once again, we build it for doing thermoform tooling, but we constantly are evolving and improving upon it. So we had air-conditioned shop and things like that since it was constructed. But in the last year, we've actually redone all that and spent over $100,000 just on air conditioning out in the shop to control the temperature of the shop to within less than plus or minus 2 degrees Fahrenheit. And that is wonderful, of course, for the employees and the people working every day, but it's really a necessity in terms of the accuracy of the tooling. When we talk about holding plus or minus 2 to 4 10,000ths punch to die clearances and things like that that make our customers successful, it's very important that the temperature in the facility is held within a very tight range, because on a die shoe, if you have a 50 or 60-inch die shoe and you change the temperature of that workpiece by a degree, it moves more than 1 thou. So multiple of our clearances we're talking about maintaining between punches and dies. So it results in punches and dies not being located properly, colliding or rubbing together, and again, not being able to have interchangeable parts, things like that. So once again, a big investment just in air conditioning. The pictures you see here, what we did, we created a precision area in the shop. And to do that and maintain and allow the piece of equipment that we bought, which is very high end, very accurate piece of equipment, we broke up the floor in over half the building and poured 1 meter thick of concrete in that area to support those machines. So it gives us flexibility about being able to move machines around without having individual foundations under the machines. But more importantly, it gives those machines the rigid surface, an unmoving surface that allows the accuracy of the machines without any twisting and whatnot to, again, allow us to produce the quality punches, dies, die shoes to the very tight tolerances that we're talking about. We're always amazed, out of curiosity, we oftentimes drive by some of our competitors' facilities when we're in the area, and when we see garage doors and overhead doors open in the heat of summer, it just tells us that there's no way possible for them to hold the clearances and accuracy that we're able to do here on our tooling. And quite honestly, we've seen that in terms of our customers bringing tooling, things like that to us that somebody else has produced, and it doesn't last, it doesn't hold up well, it doesn't have good trim quality. And once they start to realize the benefits of us and our methodologies, our equipment, our facility, and the time we take and attention to detail, they start to get the benefit out of that tooling, and we see them after that being a constant customer with us and sending us all their trim tools. So it definitely makes a difference in the industry we're in, and we're going to continue to that investment, and we'll talk about that a little bit later in the presentation with some equipment that we have coming. Let's talk about our sales process next. So something we believe we do quite different than everyone else. We don't have, if you will, salespeople. We have project engineers. So the bulk of the people that are in that group, in that department, either came out of our engineering group, came out of our manufacturing group, so they have, or out of our processing group in terms of running equipment and things like that. So they all have a lot of information, knowledge, and things like that that they bring to the table when customers send in a product for us to quote. We're not just checking boxes and saying, okay, it's a stripper plate, it's a clamp plate, we'll send it in. We're looking at that product design and trying to understand what's going to be difficult to form, what's going to cause our customers headaches, what may be issues with that tooling that it's going to be problematic down the road for them, bad punch to die conditions, stripping issues, things like this, or maybe even things that are going to drive the cost of the tooling up. And we have those conversations up front at the time of quoting where we can kind of help guide customers into a better product design that's more manufacturable, it's easier to hold tolerances on the part in regard to things that may not make that difference in terms of the part itself. It can help reduce the cost of the tooling, or once again, make it easier to support, make it easier to manufacture because of what we can suggest along the way. Once again, manufacturing knowledge, processing knowledge, tool design knowledge, all this comes together with the individuals in that group, and they're offering that assistance and that information up at the time of quote. If we're lucky enough to be awarded the job, those same individuals then manage that project from the point in time the order is received through the startup of the tool, any post-sales support and expertise, maybe even traveling to the customer's facility to support it at the point of startup. Once again, being part of the Brown Machine Group, in the past, we had all this vast knowledge on building tooling, but we really didn't have the process experience, how to adjust the machine, how to adjust the process, set the machine up, things like that. Now being part of the Brown Machine Group, we also have our group of people up at Brown that can help support that. So we can put somebody from Freeman, from Brown, from MAS, if there's packaging equipment on the back of it, all working together to support that project, make it successful. Once again, from the time of order to the time of putting parts in the box and the process being up and running. So we really look at these people as being an extension of the customer here within Freeman's facility, advocating along the way, asking questions, being the conduit between us and the design and the tool build, the startup, et cetera, and the customer. So it's really worked out well. Again, it gives our customers access to a lot of talent, a lot of knowledge that internally they may not have. Moving on to our engineering department, next step in the process. So we have, I'm proud to say, just added another full-time tooling engineer. We're actually looking for a couple more. But we have 6 full-time tool designers and 3 process engineers. So to differentiate between those two groups a little bit, the tooling engineers are the gentlemen doing the design, doing the creation of the tooling, doing all the calculations for airflow, water, heat removal, things like that. And again, doing all the design work and the modeling of the tooling. Process engineers then get that handed off to them, and they figure out which pieces of equipment and how we're going to go about making that tooling. They play a role in making sure that we are able to hold the tolerances based on the equipment we pick, based on the processes we use, the tooling we use, the material, how we're going to hold on to it. And most importantly, another aspect that they play is they put down estimated time so we know how long it's going to take to build that tool and have that in our MRP ERP system. But once again, diverse background of people in here. We have many of them with 4-year engineering degrees, and we have some other folks that have come up through be it manufacturing, machining, etc., and have also taken classes and things like that. So they've got a good group of experienced people in there coming from a lot of background, a lot of educational levels that work together and have, of course, the knowledge of designing tooling for form and post trim, sharp edge tooling, tilt molds, form trim stack, form fill seal. So we bring all that knowledge together, and there's a lot of shared things in between those different processes that these people are all well versed in. So it all comes together to help improve whatever project they're working on. The other thing we do is we have customer kickoffs, either on site or via web access type things that we do. And we offer that up to every project. We want to get as many people from the customer involved in that so that they can have insight and input into what we're going to design and build. We want to know what's worked for them in the past, what their standards are, what they like, what they don't like, what we can improve upon, so that we deliver at the end exactly what they want. So there's multiple opportunities throughout the process to have reviews, and then of course the customer gets a sign off on it at the end. And once again, we encourage as many people, not only from the design aspect and project management of the customer, but certainly from the floor level. They're the ones that are going to have to live with it. They oftentimes have a lot of good insight in terms of what makes tooling work well, and without a doubt, having everybody involved gives everyone some ownership of it and makes for more successful projects. So we'll take as much time throughout the process to allow as many people to be involved in that as we possibly can, and of course get their insight, their input, and work with them on coming up with the best solutions. During the design process, the customer also has obviously our project engineer in the front of it, but on the other side we have the designers that are actually working on the tooling, and the customer has direct access to them as well. Obviously, the project manager is going to stay involved with it and be part of it as needed, but we like to have the designer talking directly to the customer. That way, there's not a loss of information or a delay in getting that information back and forth. So that's worked out for us quite well, and we found that our customers appreciate that access. Once again, I mentioned earlier, the guys in there have years and years of multi-discipline, multi-platform experience, and we're going to apply that to whatever tooling project you bring to us. That information is invaluable, I think, from a customer standpoint, They have their window on things, but they oftentimes don't have different types of tooling. They haven't seen things on the outside, how things are evolving, how improvements are being made. We are continually exposed to that on many platforms, and we continue to integrate that into as many different places as we can. Lynn, let me know, of course, if any questions are coming up along the way here, and we'll stop and see if you can answer those.
We haven't had any thus far, but you're about to get into the meat of the webinar.
All right, fantastic. Some of it's just the window dressing on the front, so now we get into a few details here. So our manufacturing group, we think the Freeman facility is one of, if not the best, thermoforming tool shops in the United States, if not the world. You'll see as we move forward, some of the equipment, things like that we have. We've been involved with European companies who have come to us for us to support their tooling in the States. We've traveled over there. We've been to many different tool shops, not only thermoform tool shops, but injection molding shops. And I can say without a doubt, our facility is one of the best equipped, most diverse, with the highest end, high tolerance equipment that you've seen out there. I mean, there's probably some things in aerospace and automotive that might give us a run, but outside of that, in the thermoforming world and the tooling we do, we're by far, we believe, head and shoulders above anybody else out there. So we'll show you a little bit about that as we go through that with some pictures and some input coming up. But just to give us a little bit of baseline things on here, we continually invest in equipment. That's gone on for years and years. Ever since the facility was built in '97, our philosophy was to stay on top of technology, look at new ways of doing things, constantly look at what's the best piece of equipment for the job. Not only are we interested in equipment, we're interested in software, processes, technology, and things like that. So as I mentioned, we have an MRP ERP system. We completely schedule every move, every part through the facility. So we can track things from the material that was purchased, what lots it came through, when it came in the building, who touched it, to what job, what machine it went on, who ran it, what time they ran it, and when it was completed, inspected, etc. So we know all that, all the moves, all the times. We have very, very accurate tracking of parts. Our CAD to MRP ERP system, the guys are designing fully modeled tooling from screws, nuts, bolts to obviously all the manufactured componentry. That is automatically loaded from our CAD system into our MRP ERP system, expediting that process, taking the opportunity for errors out of it, etc. along the way. And that washes clean through to our purchasing group, where they can then pull those same models, same information out and buy materials, things like that in almost an automated fashion. So makes us very, very accurate and productive in pushing that through. And again, it takes time out of the whole process. From the standpoint of our CAM software out in the shop, so we have many CAM packages, not just one that's kind of a broad brush across all the different disciplines, from mill turn to 5-axis machining to wire EDM, standard 3 and 4-axis machining, grinding. We've bought CAM packages that are the best in each class, once again, to give us the ability to put the best surface finishes, the best tool path on things. Again, makes higher quality products, requires less time, and of course, improve the accuracy on things. All this has driven a lot of our automation and things like that, have driven a great deal of process standardization. So what that allows us to do is, if we're making something and we've developed a procedure and process and method for doing it that creates an accurate part, creates a good finish on a part, we get that every time when we deploy that type of activity. It's not, it was done today one way, done a different way tomorrow, and next week something else, a different way. So again, it helps guarantee our customers that they're going to get the same quality, the same fits in a timely basis out of our tooling time and time again. We're not reinventing the wheel. We're just continuing to improve the process each time we do it. And at the end of the day, we've got some real-time equipment utilization monitoring, so we can go out and look at all the equipment out there, understand how much it's ran, if it hasn't run, what's the issue, and not and work towards troubleshooting those problems and making improvements. Again, takes lead times out, takes run time, reduces it, lowers costs, allows us to produce the highest quality, most productive equipment with realistic prices in a reasonable amount of time. Some of the things we deploy out here to do that is 5-axis high-speed milling. So we have a multitude of 5-axis machines, some of them loaded with automatic robotics, linear robots, things like that, which we'll show a couple pictures of. But what you're seeing a picture of right here is the corner of a cavity. So kind of a close-up on that. That's a 5-axis part that we run. And on that, you can see that's right out of the machine. So you can see the surface finish requires very, very little hand polishing or any activities like that. All the vent drill holes are put in the machine, not by hand. We have control in making sure that those vent drills are there. They broke through, not missing. We don't have a broken drill bit somewhere. We laser check that drill when it's done for length or breakage. So if it would break, the machine will stop, pass that part out of it, flag that part. We know right where to look to understand where the issues might be. So once again, it improved quality, consistent quality, and accuracy of the parts, and not a lot of hand finishing. The other thing it does, being able to 5-axis these parts on the back side, is the cooling circuit and the water and whatnot in them. We're able to push that water up very close to the cavity surface, up the sidewalls, up the top where you have a lot of material thickness also, and get the heat out of those parts very evenly and with a lot of water in cavities and things like that. So again, reduces cycle times, makes the tooling more efficient. Talk a little bit about automation. So we've got a lot of pallet changers, we've got FANUC robots, linear robots, a lot of things to use throughout the facility to automate processes, let us run lights out, make use of this equipment that we've bought, and as well not having a man stand there and just push buttons and watch for something to happen. We very often will have people running a multitude of machines where they're staying ahead of it, loading the pallet changer, loading the robot, magazine and whatnot, and then they're on to running another machine. Once again, keeps us cost competitive. Even though we have the best equipment out there, we run it, we get high utilization out of it. That keeps our costs under control, and as well allows us to deploy a lot of standardization in terms of the pallets, the mounting in between different machines and whatnot. It's driven that so that if one machine would be down, we can very easily move the pallet to another machine, pick it up and run it over there. You're seeing a couple pictures there. Inside on the left-hand side there is a multi-axis lathe, which you normally would think would make round parts, but we can actually mill and make non-round parts in there just as easily. So once again, you can transfer a part out of there into a milling machine with very little issue or delay because of our standardization in processes and fixture. Again, another picture of that robot. So once again, that robot would use that mainly for round componentry. So you take a cup cavity, for instance, and you take the round piece of billet. The robot would load that into that machine in the main spindle. The machine would mill, drill, tap, turn on the bottom of the cavity, let's say, transfer it to a sub spindle. The robot would put another piece in the main while that work was going on again in the main spindle. In the sub spindle, that machine's also going to be cutting the cavitation, doing the vent drilling, doing any engraving. And the next time that robot interacts with the machine, it's going to take a completed part out, put it in the drawer untouched by a person. And we've essentially machined, if it was round, inside, outside, top, bottom. If it was non-round, we've done all 6 sides without a person even touching it. Again, another picture of our linear robot loading up one of the milling machines. A wider view of that, so we have a 40 station stock station there, and in that we can have round parts, non-round parts, job A, B, C, D. Doesn't really matter, and we can run things out of sequence. We can run one to test things. If a customer wanted to get, let's just say, a cavity ahead of all the rest of them, that's not a problem. There's no additional charge for that because we've, again, designed around a lot of standardization. It doesn't make any difference to that machine or the robot whether it takes the, whatever, let's just say it's a rectangular cavity out and runs it first. And before running the other 20 of them, it runs an egg-shaped cavity. So we can run one egg-shaped cavity, send it to a customer, or internally pull samples off of it, do some testing while we're in the midst of running other things. So it gives us a lot of flexibility. Also gives our customers a lot of options in terms of if they want to see a part ahead of time or if we want to do just certain aspects of things before or after with no additional cost, once again, because of the standardization. Looking at our large plate machining. So we have two of these large Mitsui CT machines. Again, it's a palletized machine. You can see there's through the glass there to the right, there's one pallet inside the machine. The second one is outside. So again, our goal here is to have the best equipment available. It's the most accurate, precise, highest uptime, all these things. But again, to pay for that type of equipment and keep ourselves competitive, we've got to utilize automation and all the capacities of the machine. So on this, for instance, outside the tombstone that you're seeing outside of the machine, we can load parts on 4 sides of that tombstone or pallet. So they're prepared, ready to go. The programs are downloaded to the machine. When the machine is finished with the plate that is inside of it right now, that big garage door opens up, that pallet comes out, second pallet goes in, machine engages the part that you see sitting outside right now, while our people are swapping out the part that's on the other tombstone. So again, we can keep this machine running. We're probing inside the machine. We're laser checking tools. We're using tool life management. So it's a very automated process that doesn't require a lot of human intervention. We're making use of the technology. And again, standardized parts, standard quality you can count on time after time. We have 2 of these pieces of equipment. So we have some redundancy. If this machine would break, there's a sister machine right next to it that we can go back and forth on. And once again, run a lot of unattended time 24/7 on these machines as our schedules and shop load requires. Moving on from there, we'll go into a little bit of some of the things that really set us apart. And that is our precision area, to which we have a jig grinder. So you see a picture of a very nice Hauser jig grinder, very specialized piece of equipment, very, very accurate, holds things down to 1/10,000th of an inch. So we fully contour, as you can see on the right-hand picture there, we would do dowel holes and trim contours for punches in this machine for the most part. So that machine, again, very, very accurate. What that means to our customer is you'll see a lot of drawings come from other vendors, things like that, and tooling that we've repaired, reworked, redone, where they'll have a punch and a die drawing that will just say, maintain 2 to 4/10 punch to die clearance. If you've ever received anything from Freeman, you're going to see that the individual punch and die is toleranced with a specific size and a profile tolerance for the trim, and as well size and positional tolerance for the locating features, dowel holes, let's just say. And the reason for that is we truly make those components to that print, to that accuracy level. Other people are making things, they're hard milling, they're doing things like that, and they're fitting things together. And that's why you end up painting parts. That's why punches and dies rub together and they wear out quickly, or your trim quality is not consistent around the periphery of the parts or from position 1 to position 2 within the trim tool. What we do is we're making the parts truly to the tolerances and the accuracy that is required to support thermoform tooling, paper tread tooling, fine blanking, and things like that. We have this capability in-house. We have the machine, we have the people with the knowledge, we have the facility with the consistent temperatures to do it, and we do it day in and day out. And once again, these are some of the things that set our tooling apart from our customers. I mentioned before, thermal growth, things like that. And then I also mentioned that other people will claim to be able to hard mill things to these same accuracies. Believe me, if that was possible, we would be doing it. We've tried time and time again. We'll show you another piece of equipment and some other things we have in-house that are really, really super accurate machines that can hard mill or better than anything else available out there in the market. And you cannot hard mill punches and dies to the levels of accuracy that we require without getting taper or tool degradation, tool deflection, things like that, that give you the consistent trim quality as what you can get by either jig grinding or wire EDMing on the very, very high end wire EDM machines, which we have in-house, with the right processes. So again, we've seen this time and time again. Other people's tools come in, we CMM them, we inspect them, and we find out they're nowhere near as accurate as what the competitors are claiming. Certainly a cost of this, but once again, we're trying to deploy these things in a very, very efficient manner to control our costs and still provide our customers with the absolute best, highest quality punch-to-die componentry and tools that can be built and are available out there.
Mike?
Yeah, Lynn, sure.
Before you continue on, I have heard a rumor within our company that you are receiving some new equipment down there.
Yep.
Is that true?
Absolutely right. Appreciate that. Thanks for teeing that up for me.
No problem.
We are, in fact, excited to be receiving here by end of December, 1st of January, an additional Jig Grinder. It's a custom-built solution that we've worked with the provider on, and I'm proud to say that it's going to add more than double our capacity, because it provides us not only with another machine, but it also, the way we've designed this, the way we've spec'd this out, some of the things we're working on to specialize and add to it here at Freeman, we're going to be able to jig grind parts in an automated, unattended fashion. So it's going to have a robot that loads that machine and a lot of software on board and capabilities on board and external to it that are going to allow us to, once again, run that machine unattended, probe parts before, after, during the production process, and have the machine auto adjust and actually, like I say, drastically increase our capacity for jig grinding in-house here, and improve probably to some degree, although minutely when you're talking tenths to start with, our accuracy over the machine we have right now that's just phenomenally accurate. So really excited about that. It's going to be kind of a whole new era for us in doing this kind of work in terms of automating it. And quite honestly, it's something that nobody else is doing anywhere. Another machine that fits right into this same accuracy aspect is our Jig Board. So you're looking at a nice Yazda jig boring machine here. What we do on that machine is nothing but die shoes, die risers, mounting plates, things like that for the trim tool. So once again, a machine capable of 10th type accuracies. And what we're doing on that, and you can see the one die shoe pictured in the machine on the right, we're going to do any dowel hole locations, guide pin and bushing bores, or if there was punch to die round pilots and things like that. We're going to put those features in that die shoe after it's already obviously been purchased, stress relieved, a rough machine allowed to sit again in stress relieved, surface ground down to less than a thou, flat and parallel before it even enters into this machine. But once again, this machine is going to make those locating and guiding features ultra accurate. So when we bolt those punches and dies that we made for you on top of them, the whole thing fits together, provides interchangeability, provides proper punch to die clearances, and again, gets you the absolute best conditions you can have for a good, long-lasting trim that holds its quality. And if you would need to replace a part, you, and honestly, just take the old one off, bolt the other one on. We prove this day in and day out. We have a die handler, and if you've ever been in here and to approval for a tool package that's leaving, we'll have punches and dies. We mount them on machines, we put it in the die handler, and we enter it. There's no bumping things around. There's no floating, peening, etc. We're not reaming dowel holes after it's already floated together. We bolt things together. Sometimes customers buy spare parts. They'll ask us, hey, can you swap a spare out just to make sure all this fits while I'm here? Not a problem. Take the spare out or the initial part out, put the spare in, enter the tool, and it cuts just like that. The same as it would if it was on your shop floor and you had to do that at your facility. So once again, very accurate machine. It's setting on that foundation I showed you. It's within our facility, plus or minus a couple degrees Fahrenheit in terms of the atmosphere and that it's in. And that this machine has chilling on not only the spindle, the coolant to keep those temperatures to within a degree. It also has another chiller that circulates coolant through the framework of the machine to make sure there's no latent heat from the controls, electrical drives, things like that that are causing that machine in areas of the framework to heat up and twist or whatnot. So once again, the point I want to get across here is the attention that we've given in terms of an investment and methodologies and equipment that we use to produce things to the accuracies that we're talking about here. And when you see other competitors, things like that, they don't have machinery to this level, and they don't have a facility to this level. They're not producing parts at the same accuracies that we are. We've seen it, we can prove it. Anytime that someone has some parts or a die set or whatnot, that someone says they're doing that, we welcome you to send it in. We're happy to CMM that and show you that it's not. And once again, that's usually the root of trimming problems, the longevity of the punches and dies. I mentioned being able to check things like that, proofs in the pudding. We have 2 CMM machines that are sub-10th accuracy capable. We can put full tools on them. There's some restrictions in terms of some of the sizes, but from a die set standpoint, we can fit full die sets on there, so we can check not only the shoes, we can also check punches and dies mounted on the shoes or separate. We can check some mold components that don't exceed the limitations of the machine. We can reverse engineer things in here. Oftentimes customers get things that tool packages that they don't have prints with, and have us build like a trim tool to go behind a mold that they have that's existing, or rework an existing trim tool and they don't have prints. We have the capability of reverse engineering and helping customers out with that process right there. Once again, so the parts that will run across this thing, anything that we build that goes into the trim tool that has to do with actual trimming, so it'd be punch shoe, die shoe, scrap blades, punches, dies, pre-punches, pre-dies, all those components are going to be 100% checked through our CMM equipment, and we of course would then have those inspection reports available to share with the customer and ship with the tooling, along with a 100% detailed as-built CAD package and print package for that tool. So once again, full service here. We're gonna take things, we can reverse engineer things from the beginning, or we can prove the accuracy and tolerances that we've done. Or if you have something that you're having issues with, be happy to check it and see if we can't find out what's wrong with it or what might be giving you the problems. And what you see on the machine right there happens to be from a tilt mold tool. So once again, we don't just do form and post trim. We're capable of doing all kinds of different tooling, and we'll see some more pictures of that as we move through the presentation.
Mike, is there a maximum tool size that you can inspect on these without having to turn the tool or inspect one half and then the other half?
Yeah, of course, there's some restrictions on that. The machine on the larger machine, it has a bridge on it. So as long as we can fit it within the bridge of the machine, which I believe is 50 some inches, we can get that generally within one setup. But, we have some other alternate means. If you have some plates or have a tool that's much larger and have some questions, it won't fit in the CMM. Sometimes we can pick it up with a couple different pickups and do it. Or we also have some capabilities that we can put it in, say, maybe our Jig Board, and actually inspect things within that machine, which is, as I reported here previously, is very, very accurate and has some capabilities almost in terms of the accuracy of the CMM. So we can oftentimes, if we get pushed out of the CMM, we can check some things in the Jig Board.
Okay.
Once again, mentioned tooling. So form tools. So what we can do, as you see here, a round tooling, non-round hinge containers, foam tooling. As I mentioned before, a lot of the European style, be it tilt molds, form, trim in place, form, trim, stack. We're starting to get into form, fill, seal tooling. We do tooling for the paper industry, paper cups, paper plates, bowls, things like that. So we're really broadening our horizon, but again, all within this packaging industry. We don't make parts for automotive. We don't make propellers. We don't make all kinds of other things. Our focus is on packaging tooling. That's what we've built the facility for. That's what we're experts for. That's what we bring to the table and make a difference in our customers' lives with, is our abilities to build packaging type tooling, mainly around thermoforming. Trim tooling. So once again, if we kind of walk through this from the form tool, next thing you're going to get into is the pre-punch tool. So whether we have something that runs in a vertical that is just a pre-punch tool standalone, could be a berry basket, could be some type of pierce tool like you're seeing here in these pictures. We're experts at that. Again, our tolerances and our capabilities lend to this quite well. When you look at that pre-punch tool, I think there's 200 and some pre-punch pins on that tool, entering into pre-dies with 2 to 4 10,000ths punch to die clearance on each one of those. Very important that it doesn't rub, very important that it doesn't collide. You need the accuracies and the capabilities that we have to build tooling like that and be successful. So we've gotten quite a reputation in pre-punch tooling, be it for just piercing, be it for actually punching blanks, or we're also seeing a lot of this type of tooling coming into play for scoring and things like that that will be used in tamper evidence. So we build a pretty good reputation on that. And again, stand behind everything we do. So if there would be an issue, or if there are parts that, when we check things, if they're not to the tolerances, if they're not to the accuracy that they need to be, we will not ship something to you that's like that and just move it through. We will stop, we'll let you know, we'll remake those parts. Our reputation hangs on that limb right there, and we're going to make sure we get you something that's accurate that you're successful with. No arguments at all. Perimeter tooling. So once again, round, non-round cup tooling, bowl tooling, hinge container tooling, tamper evident hinge container tooling. We do it all. All these things, no matter what you've seen here, all require the same accuracies, the same tolerances that we live with day in and day out. We manage that with our jig grinding, our jig boring, our super accurate wire EDM machines and the processes we use in them. Studer IDOD grinder, once again, all top line equipment, top line facility, and most importantly, people that make a difference and hold themselves to the Freeman level of quality and are absolutely ingrained in them not to do anything else but that. So that's what we provide. That's what we've built our reputation on. And again, we've seen our customers be successful based on that tooling that we're sending them. And the biggest, observation of that or proof of that is they continue to come back and order it again and again and again from us and send tooling that they've bought from other people to us to have us help them try and get that up to a Freeman standard. Again, different types of tooling. So here's some pictures of some form and trim and place type tooling. It could be Kiefel, could be Illig, could be Gobbler, OMV. So whether it's tilt molds, shuttle molds, form, sharp edge trim, we do it all. Once again, I think a lot of people that have bought in this European type tooling believe that the only place they can get that made, the only place they can get that worked on, repaired, or replacement tooling made is going back to the OEM or the European manufacturers. And quite honestly, that's just not the case. We've built this tooling successfully. We've reverse engineered it. We've traveled to facilities and seen how it's built. And I can tell you they don't have equipment or facilities any better than what we have here. And our knowledge in terms of this tooling is very good. And we can help you if you do have some of this type of tooling. Sharp edge type applications. So this is kind of what we cut our teeth on. We still do it. We don't go out and really seek this type of work out, but it is the type of tooling that Freeman originally started on back in the 90s, whether it was, again, picture on the right, be it solid machined or forged high type dies and hand sharpened dies in terms of that format, or whether it be on the left-hand side where we've got a nice picture of a steel rule, floating steel rule die application. Have the knowledge, have the talent, have the ability to build this type of stuff. If it complements the other work we're doing in terms of form, post trim, sharp edge trim tooling, we'll build this type of tooling for you, and we're very good at it. Once again, at the end of the day, it all comes down to the details. Just kind of have a little bit of a myriad of different pictures on here. And whether it's the accuracies required to make that Prepunch mounting plate that has 100 and some pins there sticking up, whether it's a little feed lug insert that has beveled edges that are all done in the machine and laser engraved with customer part numbers, revision levels, our job number, whether it's the attention to detail in terms of the middle picture there with our tag on it, labeled water in and out, hoses, etc. Any of these pictures just depict some of the attention to detail that you can see and is put into Freeman tooling day in and day out. It's the norm here. It's how we live. It's what we do. It's what we're known for, and it makes a difference for our customers. Another thing to point out, our expertise here at Freeman is, as I mentioned before, in making tooling. That's what we're experts at. We've gained the ability to rely on our brothers up at Brown and at NAS for processing expertise, machine information, machine details on the end of the thermoformers, and as well from NAS in terms of what we can offer in terms of packaging and boxing and things like that, counting on the back end from automation. But one of the things that's been a big item of interest for our customers here at Freeman, we have a small cut in place former and sharp edge, one-up sharp edge type trim tool that we can do very small sample runs on, do some test cutting, things like that. But up at Brown in the lab, they of course have the capability to have a former up there and a sharp edge or match metal trim press. So again, if more of a test or more of a sample run is required, we can work with them on that and the customers, and we can get small production runs done, larger sampling runs done, things like that. A little bit more of a production-like environment up there opposed to a cut sheet former that we have here in Fremont. So once again, a really nice addition that we can bring as the Brown Machine Group to our customers. At the end of the day, most important thing we have here is our people. So I'm proud to say we have a staff of people who are dedicated day in and day out to producing things the Freeman way of doing stuff, top quality, spare no expense, make sure it's the most accurate, because that's what's going to get customers to come back to us at the end of the day. You can see our group here, guys in engineering, process, manufacturing, design, standing around a large tool we built. And then on the right, the team that we sent to a manufacturing day event at our local college where we did some tooling and ran some parts, not only with our people taking the lead on it, but involving you can see, I think, the 4 young men there on the right-hand side who are students at the local technical school. So we invest in that. We invest in people. You're going to see in this next picture here, educating. So we'll bring people into our shop, be it from kindergarten kids up through high school, college, whatever. Doors are always open. We always participate in this type of stuff, hopefully to get some other younger people interested in the trade, give them some options, let them know what kind of work opportunities are out there. Once again, our investment in technology, there's robots, there's high-tech machines, equipment, lasers, all kinds of things here that we have that we really want to get the youth interested in. And I'm proud to say that our average age of our employee here at Freeman is about 37 years old, which says a lot to our dedication and commitment to educating and bringing people in here and keeping this going. It's good for us to bring new ideas, that fire in the belly into the facility, if you will, people wanting to try new things. And it's important to our customers because they know we're on the cutting edge of technology and we're invested in people and a young workforce that we're going to be here for a long time to support. Then finally, another thing we're really proud of is we produce all this tooling from design to manufacturing it here in the United States. So something I think that doesn't go on as much as it should. People start looking overseas and things like that. That's not the case. We don't do any of that here. We source as much of the materials as we can here in the States, buy the top quality materials, because again, we can put all the accuracy in it we want, but if we have materials that aren't stable or are subpar, prone to cracking, et cetera, et cetera, won't hold an edge, and your trim tool is not going to provide you with the longevity you want. So once again, our commitment to our people, the area, our customers, and of course, to building things here in the United States. That ends the presentation. I don't know, Lynn, if we had any questions pop up along the way. Lynn, I'm having trouble hearing you. I don't know if anybody else can, but I can't hear you at this point. I'll take a look back here through the chat myself.
No, I'm sorry, Mike. I had muted myself for background noise. I said we have a very quiet group today. There are no questions, so you must have explained yourself very well.
Well, all right. Hopefully everybody got something out of it, learned a little bit about Freeman and our capabilities here. Once again, we're very proud of the facility. There's a lot of people here who do a lot of work every day to maintain that, to keep it up, and to do everything we do here. I would invite anyone, if you have any inquiries, obviously to reach out to us at sales@brownmachinegroup.com, or of course, look for us on social media. But at the end of the day, if you're ever in the area, we're in wonderful Fremont, Ohio. It's fairly convenient to the Ohio Turnpike, things like that. Route 75 north and south, 80, 90 east and west. If you ever get in the area, or if you have any interest applications, things like that, reach out to us, come visit us. We'd love to take you for a tour of the facility, see what we can do to work with you. Thank everybody again for taking the time, and wish everybody a happy weekend. Thank you.